Hello, everyone. Good morning, afternoon, evening, from whichever time zone you might be joining us in from today. My name is Rebecca Cronin, and I'm one of the customer success managers here with the Altair Data Analytics team. The customer success team, we're here as another point of contact for you to reach out at any time with any questions, concerns you may have regarding Altair solutions. And if you're unable to get a hold of your account manager, we'll be glad to help and provide assistance. We're excited that you're joining us today for our very first Ask the Expert AI Studio AI Hub webinar series. Our goal for these sessions is to provide an open time slot where you may freely drop in, and we'll do our very best to provide any assistance in answering any and all questions after we demonstrate our topic segment. So we'll begin the session in just a few minutes, but before we dive in, I'd like to provide a little bit of housekeeping items. So on the right side, perhaps you might have a control panel, and you'll notice a handout section. You'll find one document, which happens to be a copy of today's PowerPoint slides that you may download for your reference. Next, if you locate the chat or question panel, it's the opportunity for you to submit any questions you may have during our session. So please note that the questions that you submit can only be seen by us hosts and panelists. So if you would like a question to be answered offline, please make sure you add that comment when you submit your question. Otherwise, we're going to share that question with everyone in attendance today. We will do our very best to get to all the questions as time allows. And if we don't get a chance to do so, we'll respond back within 2 to 5 business days. And if necessary, we'll forward that on to our technical support team, who can then do further follow-up assistance. And if you find any colleague that would be interested, please forward that invitation to them so they can come and join as well. Now, I'd like to introduce you to our expert today. It's Jeff Chowaniec. He is one of our senior data scientists. He's worked for almost 10 years in various technical support roles, including that of Altair RapidMiner. Jeff is actually one of our original RapidMiner specialists, and we're fortunate to have his expertise. He leads by example, providing tremendous assistance to both our customers and our own internal teams. Some of you may even have the benefit of working with Jeff. So with no further ado, I'm going to locate Jeff and make him the presenter, and where we're going to start our topic with the time series forecasting segment. And so we're handing this over to you, Jeff. And I see your AI Studio, but don't hear any volume.
Can you hear me now?
I hear you now. Perfect.
Awesome. Thank you, Rebecca. Yeah, welcome everybody. I'm excited to be joining you as the expert for AI Studio and AI Hub. As Rebecca mentioned, I come from the RapidMiner world of things, so I've been using this product for almost a decade now. And I decided on doing kind of a time series data engineering for the first Ask the Expert. For the most part, this is something near and dear to my heart. I work with a lot of clients, especially now after having been a part of Altair for a few years since the acquisition of RapidMiner. We exist in the realm of engineering, as one component of the Altair business, the kind of the engineering simulation software that we provide. I've interfaced with a lot of engineers over the last 2 years. And along with other clients as well in the manufacturing space, I get a lot of time series sensor data. So I'm going to quickly just run a workflow here, which is just connecting to my turbofan data set. But taking a look at my data, what I spend a ton of time on is building projects that utilize time series data, whether it's sensor data or not. I'm using a sensor data as an example here, for various solutions. And I also teach this a lot to clients that I'm building data science projects out with. So what I wanted to do is use the Ask the Expert as like a little PSA on, hey, how do we handle time series data in AI Studio? Because this comes up so much with projects I'm working on and with our clients that I work with, I really wanted to have a focus session on how we turn time series data into something useful for machine learning. So that's really the whole focus. I'm not looking at forecasting in terms of I have a value in a column and I want to forecast out what it looks like in the next hour, day, week, month, etc. I want to structure data for the purposes of building a machine learning model, but that data is in the format of a time series. So I grabbed sensor data because it's kind of the easiest to work with. And I'm actually going to make this simpler and just do a second select attributes here so I can grab a smaller data set for me to work with. I'll do an include and just grab a subset, and I'm just going to grab some random sensors here, I think. Perfect. So that way I'm not looking at a whole lot. But if I run this, I can just grab these sensor outputs. Now, normally I'd be taking in a column, whether it's remaining useful life, downtime, predictive maintenance, something. I want to build a prediction, right? And I've got time series data, and feeding these individual rows often aren't enough information for me to make a good prediction. Like for example, if I'm working with a any sort of manufacturing client where they're producing something and they want to maybe analyze what sensors are driving a given KPI on a product to reduce waste, I might say like, hey, it's important to know what's going on at the very second and what our outcome is. But there's scenarios in which what we want to do is actually look at a window of data and build our data set from that window. And that's exactly what I want to do with these sensor measurements. I want to talk about a very important operator, which is process windows. I probably could spend a whole 8-hour day just working with this and showing people how to leverage it. But our process windows is basically the way we take time series data and turn it into a data set that I can make predictions on. There's nothing stopping me from leveraging this data. So row by row, I can make predictions with it. But there's a lot more information I can get out of, because it's one thing to know what the sensors are doing at this very moment. But what I want to know is, hey, what has this sensor been doing over time? Has it been changing? Has it been fluctuating? What is that? How can I quantify that change? Can I take the slope of that change? Is this millisecond data? Should I be looking at something like a fast Fourier transform to see, hey, how is this data changing in this window? The nice thing about that is all of those questions I just asked on how to format that time series data, process windows does it all for me. In particular, the process windows is a sub-process workflow. So what you'll notice is my select attributes here, they don't have a layer to them. My process windows actually requires me to build a workflow inside of it. It's a sub-process operator. And what I'm going to do is leverage my parameters to say, actually, I'm only delivering 3 columns. So I'm going to leave this as all for the selected attributes. I can define my window size. So for example, if I picked 1,000 here, let's say I have millisecond data. So 1,000 data points will just simply be my 1 second of data that I'm pulling from this data set. If I had a time unit in here, I could select time-based and say, hey, this is what we have. I'm just going to go example-based because I don't have a time series in there. Same thing with the has indices. So if I do have a date timestamp or timestamp in there, I can select that. For our case, I'm going to say, hey, look at this every second, and we're going to step size every half-second interval. And then I don't have a horizon I'm looking at, so I'm going to uncheck that. And so what this is going to do for me now, if I come inside of this process windows, what I basically said is give me 1,000 data point data set, which if we have millisecond data means I'm looking at a 1 second window, and I'm moving this window a half second at a time. I'm going to just quickly throw in a third select attributes to show you what this is doing. Breakpoint after. So when I run this, what it's doing for me is it's creating these 1,000 data point data sets for me. So if I've got millisecond data, I'm looking at, this is a data set representing 1 second in my data. And what I want to do with this is, now that I have the data for this 1 second, I want to create one row of data to explain what happens to these sensors in this window. I can do that with a handful of operators, and that's essentially what this process windows allows me to do. I want to take an amount of data in my time series and use operators to paint a picture of what is happening in this window over those given sensors. What I'm going to do is I'm going to grab a multiply operator because I'm going to send this data out to multiple locations. And what I'll do is I'll grab a handful of operators like extract aggregates, which will allow me to grab stuff like my mean, my min, my max, my standard deviation over this window. And then I will grab a polynomial fit. I need to be able to spell though. There we go. Extract coefficients, polynomial fit. So I'm going to send this there. And then the last thing that I could do is something like my fast Fourier transform. So what I'll get out of this, if I throw a breakpoint after this extract aggregates, I will now take each of my sensors, if I fit all column widths here, and I will get my sensor 5 mean, my sensor 5 min, my max and standard deviation. I'll get my sensor 11 min, max, average, and standard deviation, and I'll get the same output for sensor 17. So I've taken that 1 second of data and said, okay, I've got millisecond outputs. Give me these outcomes here as columns in my data set. So what this will do is for every window, as I move that half second through my data, I will get a row of data for each window I'm creating in my data set. So the end result, I'll show off the coefficient, etc., is if I append all of this together and run this, my end result is I'll get a new data set, which gives me my window ID, which if I had a date timestamp in here, it would just tell me last date time in window. So it would take that millisecond 1000 in every window and use that as our timestamp. And here, I basically append this all together. So I take my 250,000 rows of data and turn it into 529 data points that represent windows of time. So now instead of saying, hey, here's what the sensor value is doing at this moment, it's, hey, here's what this sensor did in this window, for example. If I go to the design view, and I'm going to jump back into my process windows. If I want to grab some other pieces of information out, like for example, I want to come in here and say, hey, I want to look at, let's look at the data in this window. So if I go to visualizations, and I'm going to look at line here, and let's ignore sensor measurement 5 since it's static. I'm going to look at sensor measurement 17. This bounces all around, so this is probably a good case for my FFT. I don't know if I necessarily need to do a polynomial fit here. Let me take a look at sensor 11. as well. Yeah, I'll do this. So what I'm looking for is like a general trend in my data, right? If I have a downward slope, I probably just want to say, hey, I want to take the slope of this line in this view and see what it's doing. Here I might just get a 0 or a slightly negative slope, which is fine with me. So what I'm going to say is give me a first order polynomial for, I'm going to take sensor 11 here, and include the time series name. And what I'll get out of this, if I do a breakpoint after, is I should get my slope, which is coefficient 0, my intercept, which is coefficient 1, and my fit description, so the error of that fit, for example. So what I can do is say, okay, if I'm interested in keeping the fit description, the error, I can, but in this case, I just want the slope. So I'm just going to quickly select the slope as the item I want to keep in my data set. And then I'm just going to use a merge attributes to slam these together. So now I will bring in that slope, removing my breakpoints very quickly. I will bring in that slope to the aggregates that I've pulled out. So over here on the end, you'll find my slope. If I do a fit all column widths and come over here, you'll see my polynomial fit coefficient 0 for sensor measurement 11. Then if I want to take my fast Fourier transform and say, hey, I want to look at sensor 17, because that had all of that fluctuation in there. I want to calculate frequency. That looks good. So if I send this out and do a breakpoint after this, I'm going to hit stop, run this. What I'll get is I'll get this frequency output. I'm going to go for my line chart. I think I want to remove filter example range. 1 and 1. I'm going to remove that initial filter, or remove that initial data point. Run this and look at my visualizations here. So now I have my frequency amplitude chart, and what I could do is say, hey, I want to extract peak amplitudes out of this. So I'll go to my design view and leverage and extract peaks, which is another time series operator, and say, hey, do this for single. I want to look at amplitude, and we'll do z-score. I'll take the top 3 peaks, and I'm only interested in maxima. And then if I run this, what I should get out is a peak output, which gives me my position, my the amplitude or the peak type, etc. And I actually want to see if I can get the peak out as well. Nope, I'm going to take my feature here. Add time series name is what I wanted to do. There we go. If I run this, so now I have my sensor measurement. Oh, I'm looking at the wrong output, that's why. There we go. Breakpoint after. So if I run this, now I'm extracting out the peak amplitude for sensor measurement 17. That's amplitude peak 1. And what I could do is just say there's a lot of information in there. I'm just going to grab a select attributes, and I could write a really fancy regular expression to pull what I need. I'm just going to run a quick subset to say, hey, I want the peak value for all 3 peaks. There we go. I'll hit apply. So I will know what my peak amplitudes are. And then I'm going to send that into my merge attributes. So now what I get out of this is a single row of data where I've run an aggregate extraction on our 3 sensor values, if I fit all column widths here. So I get my min, max, average, and standard deviation in that window for my sensors. I get the slope of sensor 11, and I get my peak amplitudes out for sensor 17. And when I put this all together at the top level of my workflow, I'll run this whole thing. Got it. Let me switch this append out. What I should get out of this is a data set where I have all of these extracted data points for my 529 windows that I've generated. I can see my peak amplitudes here for sensor measurement 17, my slope for sensor measurement 11. I've got my, and then all of my aggregate extraction here. The whole point of this is I use this so often, and these are really important topics, especially in the area of like manufacturing and engineering, quality assurance engineering, etc., where I have sensor data or my clients have sensor data, and I need to turn it into something useful for making a prediction. Whether I'm predicting remaining useful life, optimizing quality of the produced product, what have you, I'm often getting data that's resolving at a really high frequency, and I need to turn it into something useful for machine learning purposes. This is how I handle that time series data generation. So when I get something that has a timestamp, especially if it's a sensor value, I'm often dropping it into this process windows, selecting a window that makes sense. Like if I've got if I have a process in which like the last 15 minutes of data is relevant and I've got second data or millisecond data going back 3 years, you know, this window size is going to be really large. And if I'm doing it indices based, I can select this by like the amount of time that I want to look at. Like if I'm switching to like a time based, for example, I can select just based off of time if I've got that indice in there. But a lot of this really just comes down to running this, looking at what my sensors are doing in that window and deciding what I want to do with each sensor. So if I come in, sensor 5 is actually kind of a bad sensor for this, if I show that, because it's a single output. So I probably needed to select a different sensor there. However, this is helpful because once I'm in my visualization side, I can decide, hey, what items do I need to actually pull out of this window? Is the window too large? Do I have a lot of data in here? Does it make sense to extract those aggregates? What type of polynomial fitting should I be doing to this data? My peak amplitude and frequency from the FFT, probably useful for this sensor, etc. So I can take a look at what this looks like in the window and then make decisions on what I want to extract out of this sensor in that window. I do this a lot. I work on a lot of use cases that leverage this. Like I mentioned in the beginning, this is a topic that's near and dear to my heart because I use this operator so often. It's helpful to basically bring awareness to it, and hopefully you guys have learned something about time series data extraction for building predictive models. All right, that's what I wanted to cover for today, and we can turn this over for 20 minutes of questions and answer anything anybody's got. If there's more you want to see, or if you want to bring up any new topics.
So you could raise your hand. We could give you the mic. Or if you're too shy, you could submit it in that question panel. Again, this is a open hour for you to take advantage and ask anything. It does not have to be just on AI Studio. If you did have something about AI Hub, could also bring that up. there's a project you're working on and you're kind of curious and how you best practice to set something up.
In any case, I'm happy to keep showing stuff. So feel free to chime in if you have any questions. So some other cool stuff we can do here is I can go back and say remove this. So something I want to highlight is I'm building this as I go for this process windows. What I can do is take this select attributes out and expand this to run on all of my features. So if I come in and say, run this, now I go from those 3 columns to 88 regular attributes. So a big portion of this is I'm running this, I'm getting these columns out. So I'm going from a handful of columns to 88 regular attributes. So something that goes hand in hand with this feature generation is also feature selection, which I could dive into as like a really big topic for another day as well. But do note that a lot of this is generating a lot more columns in my data. Not all of those columns will be useful. So something that I'm often running is basically extra feature selection after I'm generating all of these features, because my min, my max, my average, my standard deviation, they might not be helpful. So running some feature selection to say like, hey, what features are actually predictive of my label and keep those. Something I might also do is put in a little process control. Like if I know that the standard deviation for sensor measurement 1 is 0, I might want to put in a control to remove any columns with sensor measurement 1, for example. So I could pull those out, right? That's actually a good check. If I say, so let's say I do a select attributes here, and I can leverage my include and do a regular expression. And what I want to look for is anything that has standard deviation in here. So I could say dot star slash dot std space dev dot plus, which should, if I'm doing this correctly, just output the features that have standard deviation in them. So if I open this up, I should have a standard deviation for each sensor. So what I could go through and say is, okay, well, sensor measurement 1, if I go to statistics, I want to look at my sensors and see if any of the standard deviations, min and max, are 0. No, they actually look okay. So those features might fluctuate later on. Just at the beginning of my data set, they're 0. So that's interesting. That was what I was worried about, is that those features were static, but they're just static in that given window. Sensor 16 across all windows, though, has a very low standard deviation. So this is probably not a worthwhile feature to remove. But it's interesting to note that it's static in that first window that we were looking at, but the standard deviation across the whole data set is separate. So there's a lot, just because I'm generating all of these features as well. Like I mentioned, running the feature selection, because we're doing a ton of feature generation here. Not all features in every window are going to be helpful, but aggregated together, they tell a big picture story about all of my sensors. But I am essentially doing the approach of throwing everything at the wall and seeing what sticks. So because of that, it's probably good to analyze the features that you're getting out and say, hey, depending on these statistics, does keeping this feature make sense? If I've got that really low standard deviation here, I probably just want to take this feature out of my aggregate extraction because it's not fluctuating enough for me to find anything really of value in this column. So this is an easy way to dive in and say, okay, should I be extracting aggregates on this feature? It just happened that like the first window for sensor measurement, I think it was 5 we were looking at, was pretty much 0. So that feature was static in that window, but it's not static across the rest of my windows, for example. So that's a good way to check of the features that I'm generating. Are they worth generating in the first place? And so there's a bunch of other stuff I'm realizing could be a really good kind of ask the expert 20 minutes. Is like, for example, I'm leveraging the regular expression here. This is, I want to say it's predominantly the same as like standard regular expression, but it is in Java, so it might have some differences. But I leverage this regular expression a lot for either entity extraction in text data or just selecting features that I'm generating from this list, right? So if I say, hey, look for features that have a period followed by standard dev followed by any other characters, you can see these are all the matching items. So I could switch this if I wanted to look at just for like just grab the features that are just the max, or if I have the polynomial spelled correctly. Poly.plus, I bet would work. Yep. So I can grab that coefficient 0, I think dot star coefficient dot plus would give me all of the stuff, any columns that we're generating a coefficient. So you can get pretty creative with selecting the columns that you want to look at or use for a given analysis, leveraging that regular expression in the select attributes. There are a bunch of other columns that use regular expression as well, or not other columns, other operators. So if I jump into my process windows, I can leverage regular expression to select the columns that I want to operate over. And all of those time series extraction algorithms that we were using over here do the same thing. Anywhere you see this attribute filter type, that regular expression will come in pretty handy. Any questions come in the meantime?
I don't see any right now. What we could do is to give folks time. We can launch the poll question to let us know what topic you'd like to review next month. So I'm going to go ahead and do that, Jeff. So let me launch that. So for those of you that may have had Jeff's screen wide open, to vote for the next topic, you'll have to narrow down your screen. And so again, it's what would you like to cover for our October 9th session? You'll vote for your most important topic you'd like to learn because you only have one choice. So we have LLMs and RapidMiner via Hugging Face. We have model optimization, hyperparameter tuning, or as Jeff was kind of mentioning, we can review the feature selection options, or you could select other. So if there's a different type of question you might have around AI Studio or AI Hub, we do have a closing survey that will prompt you an open comment box where you could say, hey, I'd like to learn XYZ. So give you a couple of seconds there and I'll do a countdown. You can see we have a third of the attendees that's voted. So don't be shy, pick what you'd like, and if you don't like the choices, then definitely select that other. Give a couple more seconds and I'll do a countdown. Right, so we'll do a countdown. 5, 4, 3, 2, 1. All right, and the topic that was selected was the LLMs and RapidMiner via Hugging Face. So that will be our topic for October. So again, if you're too shy to ask a question, you got that chat panel there, that question panel you can submit and we can kind of review. Is there anything that you might have been struggling with or just wanted some additional clarification? And actually, I think recently, correct me if I'm wrong, Jeff, has there been like a new updated release version of Studio? Or is that version 10 that our latest version?
I think I don't know if I'm missing like a small minor version update, but 2024.0.1 is the most recent as far as I know. But there might be like a .1 or a .2 or
something like that.
Yeah. I just have so many projects I'm working with. Major releases are what I update for unless something is not working and I need the fix. Looks like we have a hand raise.
Oh, awesome. So would you like the microphone to ask your question live? But let me unmute you. And you can ask your question.
Hello, Jeff. Good morning.
Good morning.
Good morning.
So my question would be related to the sensor data which you were actually showing us. So are we going to extract any kind of decision-driven information, or is it just the standard deviation and the mean, few of the statistical data deriving from the sensor? Are we going to look at any kind of decision making on that, or how do we go ahead on data?
Yeah, so I just ignored the data set itself has a remaining useful life tag. I ignored it at the start. So if I run this, what I would do is take this status, and I can disable this. What I would normally do is take this status and do a filter example range where I want to take the status. I go here. I want to say filter example range, take the last data point in here, and then what I want to do, I want to do a filter example range, and then a select attributes where I want to include, I want to just exclude. So what I'll get out is I should get out that status here, so I can stick this. I can stick this onto the end of this data set. I think I'm going to have to adjust my step size to make sure I capture enough of them. Stop. Save. Oh, I don't want to save. But if I run this, I should now have my ID and the column I want to learn with in there. If, for example, there was a numerical output in there that is my target variable, which you can see I have the bad here. So if I go to statistics, I've got a bit of an imbalance problem, but I could start learning on this because this is my label or my target variable for this. So I could start making predictions on this right away. If, for example, I had a horizon attribute, like let's say, I don't know, sensor 21. I want to just say, hey, give me 4 horizons for sensor 21. If I run this, I should now have these horizon attributes. So if, for example, I wanted to take these 4 horizons and say like, hey, if sensor 21 is out of is 1 standard deviation away from the average of these 4 horizons, I want to output like an out of spec or an in spec prediction, right? So I can also use the horizon option here to generate these horizon variables. I could try to predict this number, or like I said, I could use these to create a label that I want to predict. I happen to already have a label in this data set. I was just ignoring it at the beginning with this select attributes. But I could easily drop in this filter example range and the select to just pull, hey, what is this status at the end of our window? So we can attribute this, the data we're extracting to this status value. And then if I wanted to, I could do something where I could take this data set run through all my windows. I could take this data set and dump it into something like AutoModel, and I could say, okay, well, let's start building a prediction on this. It knows already to predict status. I can prepare my target. You can see I have a big imbalance in my data, so I probably would want to fix this outside of that. But class of highest interest is going to be good or bad. And then I will throw on some changes here. So
basically you're trying to build a predictive model.
Yep.
Okay.
I'm going to say when we get bad, correct versus incorrect, I want to award points to that so I can weight this a little bit. And then it'll do basically tell me, hey, what's worth using based off of some statistical tests, which is correlation to our target variable, the stability or distribution of the data, are there missing values, does it look like an ID? I'm going to deselect yellow here, and then I'm going to remove a couple of other things. Like I don't need unit number, time and cycles, or the horizon attribute. But I would take all of these green values here and just say, okay, let's start making a prediction. I could select what models I want to run. I'm just going to deselect some stuff so this runs really quickly. I could include some feature selection if I want to reduce the number of features in there. But once I have that label in there, whether I'm generating it using the process Windows operator or if I have it in the data set already, I can easily say, hey, this is my target, train a model to make that prediction. I think I gave this a lot of data, so this might take a second to run each of these models. But the idea is once I've brought that data in my here, let me just output this, show examples of result. once I've got this here, as long as I've got something denoted as my label, my target variable, I can just start learning on it. So I've taken all of this transformed data and I can build models to make this status prediction, for example.
Maybe I ask you one more question regarding the design phase. How do you actually set a parameter or say that a sensor data which is extracted, what we have is just random values, you know, some values which actually a sensor has recorded. Okay, based on that, how do we initially make a call or decide you know, which data is good enough to be considered as bad, or which data is considered to be as good, and which data is considered to be as bad? How do we make a decision looking at the values?
Yeah, I mean, there's a couple of options. The easiest one is to do what the auto model was doing.
I think I hope you understood. I mean, say when a sensor has recorded a value, for example, few of the sensor has recorded a value of 1, and the same sensor has recorded a different time, it has recorded a value of 2, and then so on up to 5. Okay, now how do I say that a sensor is really performing well? Only if it is showing me the data with a value of 1. If it is showing above the value, then you know, above maybe 2 or 3, the data seems to be bad.
Yeah, I mean, I can throw a filter on there just to say filter just the values for sensor X if they're equal to a given value, greater than or less than, or I could throw on a generate attributes and say sensor 1 what do I want to say, quality flag, and I could just say if sensor measurement 1 is less than or equal to 1 or 2 or whatever the value is that you're looking at, I could output 1 for good, 0 for bad. I could throw it in, I could just say, you know, good, bad, etc. And I would get that. I don't know if sensor measurement 1 is useful for this, but if I run it, I can get that output. So it would create that column for me, and I could see, you know, am I satisfying that condition, right? There's a bunch of checks you can do. The best way to describe it is Studio is going to essentially act as a visual program. Anything you could do with writing lines of code, I have an operator for that I don't have to do any coding for. Most of the expertise and knowledge is just like knowing what language of an operator does what. Like the generate attributes allowing me to create columns using various functions. So once you're kind of thinking in how you build a process in RapidMiner, it starts to become a little bit more clear what operators help me do what.
Okay, thank you, Jeff. Thanks for the time you have spent with me. Thank you for explaining those things.
Yeah, you're welcome.
Maybe I gave opportunity to others. Thank you so much.
Thank you. That's why we're here.
Thank you very much.
Is there anyone else that'd like to ask a question? If not, I know I have some closing slides I'd like to share. So again, if you missed at the beginning, there is a handout in the handout panel section. It's a copy of today's PowerPoint. So in case you were not aware, we have the following resources. If you ever have a question about RapidMiner, or I should say AI Studio, still stuck on the old name, or AI Hub, please contact our support. You could do that right from our community portal. There's also the RapidMiner community portal, which has our discussion, blog posts, opportunity to collaborate with your peers. There's documentation. There's our Learn Academy site. And I actually got little screenshots. And like I said, we just started this webinar series, so we'll be hosting this the second Wednesday of the month. So this is that community site portal. If you haven't connected, this is that community to be able to leverage and connect with peers and some of our experts. The documentation, if you wanted to dive in. If you want to earn your certification in our RapidMiner courses, you have the Academy to leverage. There's also a learning center on the other Altair community site. I'm sure the Academy has much more, but here's another location, so you're not short of resources. And then Marketplace is where you'll find our latest RapidMiner client. Go to Data Analyst and search for that AI Studio product. If you haven't heard, we're kind of proud to brag about our Gartner announcement. We made it into the Magic Quadrant as one of the leading platforms for machine learning. It's a little, brag moment. Upcoming events. We do have a upcoming webinar hosted by our Altair team. We're doing Future AI Horizons, how to thrive in this digital world with the evolving AI landscape. So you can, again, download that handout, and you got the barcode you can scan to register, October 23rd. By the way, today's session we did start at 11 to try to accommodate some of our West Coast customers. We're actually going to push the time back, so I will update that registration page to reflect the new time. We will be starting at 11:30 a.m. Eastern. So for those that came and joined, thank you so much for being up and early, but we'll give you a half hour to do some daily work and then come join us at 11:30. So our next one, as I mentioned, is October 9th. And just a remembrance token for today, 9/11. So for those that were affected, we think of you, and we just won't pay our respects and remembrance. So again, I just want to thank everyone for joining us today. We hope you benefit. We'll do our best to get this recording uploaded to one of our YouTube channels or perhaps a blog post within our community that you can go back and replay. Thank you again, Jeff. Awesome job. And we look forward to next session. Thank you, everybody. Have a great day.
Thank you, Rebecca. Take care.
Bye-bye.
Thank you all. Bye-bye.